Lesson 3.2, complex numbers. How do you define and use the imaginary unit I? There were 5 problems left on the page for independent practice. Let's go ahead and take a closer look at those. I'm being asked to find the zeros. If I'm being asked to find the zeros, then that meant the y value, the answer is 0. So 0 equals x squared plus 7, and I'm being asked to solve for x. So I'm going to subtract 7 from each side. 0 minus 7 is a negative 7. I need to get the x by itself, so I need to take the square root of both sides. I chose to take the square root. If I chose to take the square root, I need a plus or minus. I need to separate that negative 1 from the 7. The square root of x squared is just x. So I have plus or minus. The square root of negative 1 is I. Square root of 7 is the square root of 7 because 7 is prime. You cannot prime factorize it. So this is my x value. Where does it cross the x-axis? There are 2 values. I cross at the positive I root 7, and I also cross at the negative I root 7. If I were to graph this original function, I would see it crosses the x-axis at these 2 locations. Problem number 4. I'm being asked to find the zeros. If I'm finding the zeros, that means this value right here is 0. So 0 equals 9x squared plus 1. If you don't like the 0 being on the left, you could rewrite this as 9x squared plus 1, the entire quantity, equals 0. You write it the exact way that you found it. So I'm going to subtract 1 from each side. So 9x squared equals a negative 1. Divide both sides by 9. So x squared equals a negative 1 all over 9. I need the x by itself, so we're going to take the square root of both sides. The square root of x squared gives me x. I chose to take the square root, so I need a plus or minus saying I chose. So taking the square root of a fraction, you have the square root of the numerator all over the square root of the denominator. The square root of negative 1 is I. The square root of 9 is 3. So I have 2 answers. I have the positive I over 3, and I have the negative I over 3. So this function does cross the x-axis twice. It crosses at these 2 values. Problem number 3. We're being asked to find the zeros. If we're finding the zeros, that means this answer is a 0. So 0 equals x squared minus 4. We're trying to find what values of x would make the problem equal to 0. If you don't like the 0 on the left and you want it on the right, this entire quantity was a negative x squared minus 4, and it was equaling 0. Just rewrite the entire quantity on the other side. So now we're going to go ahead and solve. We're going to add 4 to each side. So I have a negative x squared equaling 4. Divide both sides by a negative 1. So I have an x squared equaling a negative 4. I need to take the square root of both sides. The square root of x squared is x. I chose to take the square root, so I need a plus or minus saying I chose. And I needed to separate that negative 1 from the 4. So x is plus or minus. The square root of negative 1 is I. And the square root of 4 is 2. So I do have 2 answers. I say that I cross at the positive 2i, and then I also cross at the negative 2i. These are where my 2 x-intercepts occur. Problem number 5, we're being asked to find the zeros. If we're finding the zeros, that means this was supposed to be equal to 0. So I have 0 equaling a negative 2x squared plus 196. I need to solve for the x. So I'm going to subtract the 196 from each side. So I have a negative 196 equaling a negative 2x squared. I need the x squared to be by itself, so we're going to divide both sides by the negative 2. Negative 196 divided by negative 2 is a 98, so 98 equals x squared. I need to take the square root of both sides because I want the x by itself. So taking the square root of both sides, I chose to take the square root. If I chose to take the square root, I need a plus or minus. I need to prime factorize 98. And I don't know this one off the top of my head, so we're going to go ahead and use a factor tree. 98 I know is even, so I know 2 can go into it. It's 2 times a 49. 2 is prime. 49 is not prime. 49 breaks up into 7 and 7, which both of those are prime. So the square root of 198 is actually 2 times 7 times 7. Remembering if they pair up, they can escape. So my 7's escaped. My 2 did not. The square root of x squared is x. I had no square root of negative numbers in here. So this is my 2 reals. I have 2 x-intercepts, the positive 7 root 2 and the negative 7 root 2. I still found two solutions. They're both just real solutions because neither of them have an imaginary I. Problem number 6, last problem. I'm asked to find the zeros. If you're asked to find the zeros, that means this guy right here is supposed to be 0. So I have 0 equaling a 2x squared plus 216. I need to get x squared by itself, so we're going to subtract 216 from each side. Divide both sides by 2. I have negative 108 equaling an x squared. I need to get the x by itself. So we need to take the square root of both sides. I chose to take the square root. If you choose to take the square root, then I need the plus or minus. I need to separate the negative 1 from the square root of 108, equaling the square root of x squared is x. The negative 1 simplifies to I, so I have plus or minus I. I need to try and figure out what the prime factorization of 108 is. Because it's even, I know I can divide it by 2. So 2 times 54. 2 is prime, 54 is not. 54 is even, so I know he can also be multiplied by 2. He can also be divided by 2. It's 2 times 27. 2 is prime, 27 is not. 27 is 9 and 3. 9 is 3 and 3. So prime factorization of 108 is 2 times 2 times 3, 3, 3. Remember, if they pair up, they get to escape. So these 2's escape and these 3's escape. That 3 had to stay inside. So a pair of 2's escaped, a pair of 3's escaped. That 3 had to stay inside, and all this equaled x. So what does x equal? It's the positive and the negative 6i root 3. I do have two solutions, the positive 6i root 3 and the negative 6i root 3.